How PureTarget is revolutionizing research in carrier screening. Did you know that a staggering 7 out of 10 individuals unknowingly carry at least one pathogenic genetic variant, even without a family history of any diseases? This alarming reality emphasizes the pressing need for enhanced research programs focused on comprehensive carrier screening. But here's where it becomes critical. Most couples might inadvertently pass hereditary conditions to their offspring, thus highlighting the necessity for thorough advancements in genetic testing and screening methods. Carrier screening, once a specialized practice for specific conditions or defined populations, has evolved into a crucial component of conversations surrounding reproductive health for all individuals. To ensure these discussions are as impactful as possible, they should be grounded in the latest information regarding potential risks from certain inherited disorders and should include research efforts targeting specific communities that might be more affected. By making this vital information accessible, families can grasp their risk factors and make educated decisions regarding their reproductive planning. Guidelines established by reputable organizations such as the American College of Obstetricians and Gynecologists, ACOG, and the American College of Medical Genetics and Genomics, ACMG, reflect this progressive trend, urging for more inclusive and expansive screening protocols. However, as many experts point out, fulfilling these expectations has not been straightforward. The genes most essential for reproductive health are frequently the most challenging to sequence, complicating research efforts and hindering effective communication of critical information to communities that need it most. This week, PacBio has introduced an expanded PureTarget portfolio, releasing a new selection of kits that harness HiFi long-read sequencing technology to elevate the standards of carrier screening research at a massive scale. This innovative approach marks a significant advancement in how laboratories handle inherited diseases. With PureTarget, laboratories can now transition from outdated techniques such as triplet-primed PCR, MLPA, and Sanger sequencing to a comprehensive and streamlined workflow. Marriage of carrier screening and HiFi sequencing, certain genetic markers consistently pose significant hurdles in carrier screening. Notable examples include the FMR1 gene linked to Fragile X syndrome, the SMN1 gene responsible for spinal muscular atrophy, and the HBA1/2 genes associated with alpha thalassemia. Each of these genes brings unique challenges due to factors like long tandem repeat expansions, GC-rich sequences, near-identical pseudogenes, or complex structural variations, which standard short-read sequencing methods often cannot adequately address. In the past, this situation led laboratories to revert to older technologies. For instance, repeat-primed PCR was employed to ascertain repeat sizes. MLPA was used for detecting variations in copy numbers, and long-range PCR webinars were utilized to characterize structural variations. While these older methods serve their purpose, they belong to a bygone era of genetics, characterized by labor-intensive, disjointed approaches that ultimately limited their scalability. With PureTarget powered by HiFi long-read sequencing, a contemporary solution emerges, boasting impressive read lengths spanning kilobases and an accuracy exceeding 99.9%. HiFi sequencing can now effectively capture genome regions that necessitated separate methodologies in the past. Laboratories are now able to obtain everything they need from a single comprehensive long-read panel, accommodating 96 samples in one sequencing run, enhancing efficiency and consistency in data collection. Comprehensive carrier screening via long-read sequencing. The newly expanded PureTarget portfolio features 3 specialized panels. The carrier screening panel encompasses inherited conditions, inclusive of all ACMG Tier 3 genes that present significant technical challenges. The repeat expansion panel enables high-resolution evaluations of tandem repeat expansions related to neurological disorders. The control panel is tailored for labs aiming to design and validate custom assays suited to specific populations or research goals. Available in formats for 24 and 96 samples, These kits are crafted to cater to both targeted research initiatives and broad-scale projects. A single Revio system can efficiently handle the processing of up to 100,000 PureTarget samples annually, allowing laboratories to sustain their high-volume workflows while integrating a unified, modern solution, phasing out outdated multi-assay methods. For researchers, this innovation results in cleaner, more reliable datasets that reflect modern sequencing capabilities, rather than being hindered by the limitations of obsolete technologies. The consolidation promises quicker results and increases reliability across the board. The assurance of HiFi sequencing in carrier screening in the realm of genetics, precision is paramount. Accuracy directly translates to the reliability of results. Legacy methodologies often introduced elements of uncertainty. For instance, repeat-primed PCR could successfully size repeats but fell short when it came to non-canonical repeat motifs. Likewise, MLPA could provide insights on copy numbers but was unable to identify sequence alterations. In contrast, HiFi sequencing ensures that PureTarget can accurately resolve repeat expansions such as those linked to FMR1 directly, eliminating the need for PCR or southern blots. Clearly determine the full haplotype and copy number of closely related genes like SMN1 and SMN2 without reliance on MLPA. Detect substantial deletions or inversions through a singular workflow, rather than requiring multiple separate tests. As Dale Muzzy, Chief Scientific Officer at Myriad Genetics, aptly pointed out, PureTarget is a breakthrough because it focuses PacBio's outstanding long-read sequencing quality on clinically relevant, hard-to-sequence regions across many samples simultaneously. This technique not only streamlines laboratory workflows by reducing the necessity for multiple specialized assays, but also enhances the sensitivity and specificity of results. The benefits here are unmistakable. By phasing out older, fragmented technologies, PureTarget promotes higher output and simplifies the overall process, making carrier screening a broad public health initiative. Carrier screening is evolving. It is no longer confined to niche practices for selected groups. Rather, it is gaining recognition as a vital public health issue. Health systems and governmental bodies are increasingly developing national initiatives aimed at promoting broader carrier screening. For example, researchers at Berry Genomics have pioneered the application of HiFi sequencing in China, employing scalable PCR amplicon-based assays to investigate single gene disorders, including thalassemia and spinal muscular atrophy. While these endeavors underscore significant progress, developing truly comprehensive screening programs has been hampered by the inefficiencies associated with legacy assays. PureTarget offers an exciting and streamlined approach by consolidating numerous genes into one cohesive long-read sequencing workflow. This could have profound implications for population-scale health initiatives. Additionally, the benefits to research are immense, as large-scale studies can now rely on sequencing that aligns with current standards, rather than being held back by antiquated methodologies. Panels ready for future demands. For many years, the provision of comprehensive carrier screening has necessitated layering various technologies, each adding complexity and costs at every turn. Each legacy assay comes with its own validation prerequisites, service contracts, additional instruments, and technician certifications. Trying to train staff across multiple workflows often results in increased costs, and maintaining outdated equipment can drain resources long after its peak value has been reached. The expanded PureTarget portfolio eliminates the need for these cumbersome, overlapping technologies. By integrating carrier screening into a singular HiFi sequencing process, laboratories can retire outdated assays, lessen the number of service contracts, and concentrate their team's expertise on one advanced platform. This translates to reduced costs, simplified operations, and a sustainable model capable of evolving alongside advancing scientific standards. With modular capabilities, automation support, and customizable control panels, PureTarget establishes a future-ready framework designed to adapt to the evolving needs of the genetic screening landscape. Transitioning carrier screening from outdated workflows. The narrative of carrier screening up until this point has been characterized by its complexity. An array of short reads intertwined with outdated methodologies like repeat-primed PCR, MLPA, Sanger sequencing, and more, all of which were patched together. The newly unveiled PureTarget panels fundamentally alter this narrative. Old assays are replaced with cutting-edge HiFi sequencing technology. Uncertain results give way to definitive conclusions. Disjointed workflows evolve into an integrated, clear process. For laboratories, this transition signifies the establishment of sustainable programs rooted in a modern technological framework. It implies obtaining results grounded in the excellence of today's techniques rather than the inefficacies of the past. Embracing the future of carrier screening with the expanded PureTarget portfolio. PacBio is rejuvenating the field by discarding outdated and fragmented technologies in favor of the reliability and scalability offered by HiFi sequencing. This innovative approach brings clarity and assurance to large-scale carrier screening efforts. The clearer results provided by this technological leap have the potential to positively affect the health outcomes for generations to come. The future of carrier screening is available now. References Guo D. et al. 2025. Regional Patterns of Genetic Variants in Expanded Carrier Screening. A next-generation sequencing pilot study in Fujian Province, China. Frontiers in Genetics, 16, 1527228. Guha, S. et al. ACMG Laboratory Quality Assurance Committee, 2024. Laboratory Testing for Preconception Prenatal Carrier Screening, a technical standard of the American College of Medical Genetics and Genomics, ACMG. Genetics in Medicine, 26, 7, 101137. Greg A. R. et al. ACMG Professional Practice and Guidelines Committee, 2021. Screening for autosomal recessive and X-linked conditions during pregnancy and preconception. A practice resource of the American College of Medical Genetics and Genomics, ACMG. Genetics in Medicine, 2310, 1793 to 1806. Kraft, S.A., Duenas D. Wilfond, Goddard K.A., 2019. The Evolving Landscape of Expanded Carrier Screening. Challenges and Opportunities. Genetics in Medicine, 21-4, 790 to 797. Liang Q. et al., 2021. A more universal approach to comprehensive analysis of thalassemia alleles. The Journal of Molecular Diagnostics, 23-9, 1195 to 1204. Liu, Y, Chen, M, Liu, J, et al. Comprehensive Analysis of Congenital Adrenal Hyperplasia using Long-Read Sequencing. Clinical Chemistry, 68, 7, 927 to 939. Li, S, Han, X, Zhang, L, et al. 2023. An effective and universal long-read sequencing-based approach for SMN1 2+0 carrier screening through family trio analysis. Clinical Chemistry, 69, 11, 1295 to 1306.